diameter mirror is capturing more light than the human eye can on its own. And basically it's feeding it as a small bundle into your eye, into the eyepiece. Now, it would have been lovely to take you all out tonight, for those of you that are actually present in the room, and show you the night sky, but we can't do that. So what I tend to do sometimes is actually show what we would be able to see on the night sky if we went out. And here is a bit of software I use called Stellarium that's actually giving me a simulated view of the night sky. Now, think of Stellarium as a sat-nav for the sky, a night sky simulation program. You can get them these days for smartphones and tablets as well. Stellarium is just the one I happen to use because I think you've probably already established all things that are free. So this one is a free download for PCs. You can also get it as a smartphone app. I think for Android it's also free, but there's a charge for iOS. This software effectively allows you to see what the night sky would be like at any time and date, any place on the Earth, but it'll pick up your default coordinates from your smart device and give you a view of the night sky and show you what you would see if there was no cloud in the way. So I've set it up for roughly, what time have I set it for? About, yeah, it's about an hour pretty much here. And actually this is what the night sky would look like tonight. So looking south, we'd actually see there's two bright objects low on the horizon. They aren't stars, they're planets. So the brightest object in the night sky tonight will be the planet Jupiter. Pretty much slightly east of south, the brightest object in the night sky. And just to the right of it, slightly lower down, there's a fainter object, but still reasonably bright, and that's the planet Saturn. So in our southern views tonight, if you were lucky enough to have a clear sky, the two bright objects about 15, 20 degrees above the horizon will be the planets Jupiter and Saturn. And even in a pair of binoculars, you can see that Jupiter is a small disk, a small ball. And even the smallest telescopes will actually show it as a disk with bands on it, with cloud bands actually showing it. And equally true, if you look enough to see Saturn, you can actually see the rings of Saturn. Now, you can even see the rings of Saturn in a pair of binoculars. I mean, the first person to really train any optical device on these objects was Galileo some 400 years ago. And his first primitive telescope was only 25 millimeters in diameter. And he described it as seeing as a star with ears, because he could see the protrusions on the edge that we now know to be the rings. And of course, in a few years later, he managed to get better fidelity optical equipment, and he realized he was looking at an object with rings around it. He also studied Jupiter, and in fact that got him in significant trouble with the Catholic Church, because he actually saw Jupiter had moons going around it, and he realized that those objects were actually orbiting Jupiter, which he saw over several nights and plotted their orbits. And that made him realize that the current accepted view that the Earth was the center of everything and everything had to revolve around the Earth was no longer true, and there was evidence to the contrary, and that actually got him into significant trouble, in fact, and put him under house arrest for the rest of his life. He was only pardoned in the 1970s, I think. And off to the right, let's see the Milky Way going to the horizon, the bulge more of the center, getting close to the horizon right now. Now, this time of year, there are three bright stars dominating almost directly overhead and to the right and lower down. Those three stars we actually call the summer triangle. And if you find a bright star that's directly overhead, you're looking at a star called Deneb, and it's in the Northern Cross constellation. So if you look at it on here, you can see there's a cross shape where it's the head of the cross. Actually, if you extend the beam of the cross, there's two more stars to the side, and almost five in a slightly cranked line. We're actually looking at not what we would call the Northern Cross, we're actually looking at the wings of Cygnus the Swan. And what we would see as the head of the cross is actually the stubby tail of Cygnus the Swan, with the long neck of the swan coming down. That star there is called Albirio. So effectively, the swan is flying down the Milky Way. So if you find these three stars, the bright star Vega, Deneb, and beneath it Altair in the constellation Aquila, the eagle, you will see right in the middle of it the Milky Way. Now, right now, this is just a view of the night sky as dots. So it's not very useful to see. But you can use the software, you can actually switch on more information than that. So this is a simulated view of the night sky, and that's me taking a photograph of that central area, pretty much the same location, pretty much this time last year. And this is the central part of the Milky Way with the dark bands here, the gas and dust that I said before was the actual central bulge of the Milky Way. Now, this software actually does a lot more than just show you what the points of light are. We can actually wind the clock forward, or we can turn on observing aids. In this case, I've actually turned on a few different things. I've turned on labels for the stars and planets. I've turned on the constellation markers as a dot-to-dot stick kind of a figure approach. But I've also turned on the constellation art. Now, most of the constellations that we use, actually, we break the sky up into 88 individual constellations, and most of the constellations come from antiquity, and we actually use, generally speaking, the Western Greek mythology based names more often than not. A lot of the star names don't come from Greek mythology, they come from older. They're often the names, many of them are Arabic and Persian in origin. But looking at the constellation there, I showed you Deneb there and the Northern Cross. Now you can see the actual shape of the swan, actually supposed to be flying down the Milky Way. And off to the right, the bright star Vega is in the constellation of the Harp, the lyre of the harp. Now that Vega is pretty much slightly to the right overhead tonight, the brightest star pretty much directly overhead. And off the left, the one making the other part of the triangle is a star with two fainter ones, one either side. Those three effectively making the summer triangle, and the Milky Way running down beneath it. Now down here where you can see Jupiter and Saturn, and on the left we've got Aquarius, and the left of that we've actually got the fish of Pisces. That band of sky there is actually the plane of the solar system. So it's that plane that all the planets appear to orbit around the sun in. From our perspective, it describes another band around. It doesn't share the same orientation as the Milky Way, but it's a different band, and all the planets will effectively be in this area somewhere as they wrap around us. And actually, if I continue the view off the left-hand side, the other planet that's really visible in the night sky is actually a much fainter one. It's the planet Uranus. So this is actually looking directly south. And off to the right, we've actually got Ophiuchus, the serpent bearer. So if I do the same thing now and actually spin around and look at the north, here's our old friend the Plough there, sitting as part of Ursa Major. And the two stars there pointing up to the bright starish there, it's Polaris, which isn't directly overhead, of course, because at these latitudes are about 53.5, 54 degrees or so. And where the grid lines meet, that's the directly overhead point, the zenith. So there we've got Ursa Major pretty much in the same orientation as I showed the slide of my home in Preston. And if you find Polaris and go off the other side, you'll find a W shape of stars. That W shape is supposed to represent a queen sitting on a throne, Queen Cassiopeia. Now, just from the dot to dot there, I think you can see a lot of these constellations are quite fanciful. We don't, as astronomers, tend to use the stylized figures, but we do use the dot to dots as a way of actually breaking the sky into graphs. And I often say to people that even as an experienced astronomer, I don't understand the constellations and certainly don't suggest the patterns to me that came from antiquity. Some, but not many. And I think it came from when we used to sit around campfires and we'd talk before we had the written word, we'd share stories. We used the canvas of the night sky to illustrate our conversations, but I don't know what was being smoked or drunk around those campfires. For example, over on the right-hand side here, we've got Aries the Ram. Aries is effectively three stars in a slightly bent line. How you can get the famous fleece of Jason and the Argonauts fame from that, I really don't know. So continuing off the left-hand side here, we've actually got Uranus, just disappeared off the left-hand side, continue the plane down. Just coming over the horizon in the northeast, there's that little bundle of stars, the 7 stars that make up the little bundle of stars that's Pleiades, and that's appearing right now. And as the night goes on, that will rise higher, and behind that you'll see Taurus, the V-shaped head of Taurus the bull coming in the night sky. So this software I definitely recommend getting, especially if you're not used to finding your way around the night sky. It's certainly a good way of teaching yourself. And the beauty of it is you can actually stop time and study it and zoom in and actually click on an object and get much more information. You can also change the location on the Earth. You can actually say, I'm going to perhaps go on holiday to Spain if I'm lucky enough to do that. What's the night sky going to be like from Spain when I'm down there? You can change the time and date and the coordinates, and it will show you what to expect from that view. So phones and tablets these days are a really useful way of actually learning the night sky, but there's lots of other things they do as well. We mentioned before about the aurora. You can see the northern lights from the UK, especially if you've got warning that the conditions are right. You can get an app for your smartphone these days, especially one called Aurora Watch, that gives you real-time information coming from satellites detecting the particles coming from the sun. And even in daylight, we can get warnings there's a good chance perhaps of an aurora tonight. Of course, you can get smartphone versions of Stellarium, like I just discussed, or you can get other apps that help you know when the International Space Station is coming over. And there's also apps which tell you when things like meteor showers are happening. So there's a whole bunch of apps I would definitely recommend getting for your smart device these days. You can even use it to take photographs. Most people think you can take photographs of the night sky with a nice expensive camera with a very large light gathering capacity. Well, these days, smartphones have actually got very capable cameras on them. And they often have the ability to be put into complete manual mode to be able to do long exposures, as well as the automatic modes they have. And to take long exposure of the night sky, you really needed to be able to take an exposure that lasts at least a couple of seconds. So if you can modify the shutter speed and make it do long exposure in the manual settings, you want to be putting the shutter speed to at least, say it's 2 or 3 seconds. There's a couple of other settings which I probably won't go over in detail, like the sensitivity, the ISO. The higher numbers make it effectively more sensitive, but they also make background noise more visible. And also allow to focus it manually. If you can actually slide the focus so it's focused on infinity, not close up, like you're looking at something very close to you, you can actually get decent exposure. Now, some of them even have AI built into them that do all of the clever stuff for you without you having to worry about it. So much so that you can take hold and actually take an image of the night sky. And what it will do, it will take multiple images and actually stack them on top of each other. And that takes out the movement inherent in you trying to hold it steady for a period of time. So this night mode, as it shows, can even actually get a picture like this, which I took from southern Spain last year when in between the lockdowns, when I was lucky enough to take a visit in my camper van of the Milky Way setting over the Mediterranean, handheld exposures with a modern smartphone. Much easier, of course, is to use the inbuilt sensitivity and use a little tabletop tripod. Now, the tabletop tripod I'm showing on screen right now, you can download from Amazon. It only costs about £15, and literally you can fit in your pocket. And the way it works is basically you have a little clamp which attaches to the top of the tripod, and you put your phone in that clamp. And that means you can take a long exposure without the phone moving during the exposure. And that's the kind of thing you can get. This is a Milky Way shot taken of the area just above Preston on Jeffrey Hill in Longridge direction, with the Milky Way showing across the horizon. Now, this is 6 images I've taken and actually merged them together and stacked them on top of each other. You can see the fidelity you can get with a modern smartphone. You can even take pictures of when the International Space Station is going over. So here's our old friend Orion, and that streak of light there is a series of 3 or so images as the International Space Station flies through. And I've stitched them all together, showing the path of the ISS going through. And even though it's actually a reasonably bright night, the moon isn't actually saturating too much of the image here. I can actually see a night sky with a faint outer Milky Way going above Orion. So yeah, with modern smartphones these days, it's actually something you really shouldn't avoid doing. It's amazing what you can do. Just being in a dark place and taking a photo of the night sky can be quite addictive. Also, you can do some creative effects. I mentioned before that you need to see the stars moving over the night. Well, it can do a really long exposure. You can actually show the way the stars trail over the evening as they appear to rotate around the star that's the top of the screen there, which would just off the top was where the star Polaris would be. Now, this is about 2 hours of exposure taken in 2-minute or so intervals, stitched together. And the curves you see there as the stars rotating anti-clockwise, getting tighter and tighter circles as you get nearer to Polaris there. Now that's about 30-degree length of arc there, because stars move 15 degrees or so of arc per hour. There's lots of cool things you can see in the night sky. Unfortunately, some things come and go. This is a view I took of the comet Neowise, which some of you may remember was visible in the autumn sky last year, low on the horizon. A comet is basically a dirty snowball. You can see our old friend there, there's the plough, and low in the north, you can see comet Neowise. And a bit closer up, what you see in there is a comet, a dirty snowball, effectively. Now, comets are objects that are in our own solar system. Think of them as dirty snowballs that have a really elliptical orbit, spending a lot of their time in the far outer cold parts of the solar system. But because their orbits are very elliptical, when they get closer to the sun, they heat up. And what you're seeing there is the heat from the sun evaporating the ices on their surface and carrying away dust and debris in their tail. And what we see is this lovely long tail. You may just about be able to make out there's a second fainter blue tail there, and that's actually ionized gas streaming away from the comet as well. Now, bright comets don't come out very often. We haven't really had a bright comet visible in the Northern Hemisphere since probably about 1997. But this one was actually a beauty last year, and there's a possibility of another one in about 8 or 9 months, but we don't really have a good way of predicting them because the new ones tend to be very, very bright. But we do see what they leave behind. This is a meteor shower. This is the star area of Perseus in the area of the Milky Way. And at certain times of the year, probably around August the 12th or so each year, we have what we call a meteor shower, where you can say maybe up to 100, 120 shooting stars an hour. Now, a meteor, the proper name for a shooting star, is actually nothing to do with a star at all. It's actually a tiny amount of debris, usually left over by a comet. And when the Earth hits that part of space where it's residing, basically it hits the upper atmosphere and vaporizes it. And we see it as these flashes of light appearing to radiate away from a point in space. And that point in space, in this case, is in the constellation Perseus. So we call these the Perseids. And I think it's one of my favorite meteor showers of the year. You can see the moon, of course. The moon, as an astronomer, sometimes can be all light pollution, but looking through a telescope at the moon, you can see its surface is incredibly detailed with impact craters. Now, those craters are actually caused by objects hitting the moon's surface. Thankfully, millennia ago, when the solar system was still rich in this kind of bodies, in fact, the Earth was pummeled just the same way. Put it in context, that crater there is probably about 70 miles in diameter. So the moon is completely cratered by many, many impacts. It might surprise you to think, why isn't the Earth cratered in the same way? Well, it was, but the Earth has an atmosphere which has eroded many of those craters. It also has a very active tectonic surface. So the skin on top of the Earth's molten core is always moving around. So most of the Earth's surface actually is quite young. What you're seeing there is 3 to 4 billion years old activity on the Earth's surface. It really doesn't have that long rock. So I'll probably bring it to a close fairly soon. I'll show a few samples. This is a really excellent image, unfortunately not taken by me. It's taken by a very talented photographer called Damien Peach of Jupiter, the big gas planet. Now, this is the kind of thing you could probably see through a telescope tonight if you had a decent sized telescope in still air. And you can see the ball of the planet with actually its cloud bands. But sometimes you can actually see its moons passing in front of it and actually causing a shadow on the surface. So think of that. If you actually, on Jupiter's surface, inside that shadow, you'd actually be having an eclipse, not caused by the Earth's moon, but caused by one of Jupiter's moons, in this case, the moon Ganymede. Saturn, of course, is the object I would, of course, love to show people tonight. And this is another one of Damien's images of the planet Saturn, showing its all its glory with its, again, cloud bands, but also its beautiful rings. And there's a distinct gap in the rings called the Cassini division. You can see that clearly even in a small telescope. Now, we have now sent probes. Now, the next image is a view from a probe called the Cassini probe that actually showed the rings in significant detail. And we now realize the rings are actually made of thousands upon thousands of individual ringlets, themselves made upon countless numbers of small chunks of icy debris. You can even see that icy debris starting to clump together again and will form a new moon on one of the outer rings. This is the star cluster Pleiades I mentioned before, the one that's on Subaru cars. And you can see it's actually embedded in a gas cloud. And when you actually look up and close to a telescope, you can actually see the nebulosity. Nebula means cloud in Latin. And basically the nebulosity is the cloud through which the starlight is shining, making the light of the gas and the material in there glow. So it's one of my favorite objects to see. It's actually often known as the Seven Sisters, because naked eye you can see 7 stars or so, maybe 6. But through a telescope or even a small pair of binoculars, you can realize this cluster of stars has actually got dozens upon dozens of stars in there. There are gas clouds in space as well where stars are forming right now. This is the Orion Nebula. If you look at our old friend Orion with these 3 stars making his belt, well, hanging down from his belt there are 3 fainter stars. And we call that his sword. And here we actually see the center of one of those 3 fainter stars is actually not a star at all, it's a bright gas cloud. And even in a small telescope shows there are actually 4 bright stars in the center here. Now, those stars are actually formed out of the gas cloud as it collapses down under its own gravity. And effectively, that's all stars are, hot, dense balls of gas. If you happen to be in a gas cloud in space, over time, the natural gravity will tend to cause that cloud to collapse. And eventually, the temperatures and pressures will get so high in the center of the clumps where nuclear fusion will happen. The hydrogen that's mainly in the gas cloud will be pushed together so hard by the temperatures and pressures involved that it fuses and makes helium. And effectively, at that point, it gives off energy. It's being a nuclear reactor. And that's effectively what powers all stars. And there's some bright new stars formed in this stellar nursery in Orion. So there's lots of lovely things in the night sky. There's clusters of stars. I already mentioned before, astronomers aren't very good at names. So there's 2 clusters quite close together. So we call that the double cluster. And it's in the constellation Perseus, so it's the Perseus double cluster. And if you want to find it, find the W shape of stars off to the other side of Polaris to the Great Bear. Find the W shape of stars, and the line of the W coming left, there's a curve of stars that's in Perseus, and halfway in the middle is where you'll find these two. And you'll show up easily in a pair of binoculars as two little sparkles of light. Under a telescope, they actually show themselves as to be much more richly defined, and there's several hundred stars in each cluster. You even get clusters of stars where they're even more densely packed than that. This is a globular cluster because it looks like a ball of stars. And it's a globular cluster in Hercules. And in this case, we've got something like 30,000 or so stars in a relatively small space. And you can find that just to the right of the bright star Vega, which is the top right in the summer triangle of stars. And off to the right, you can see there's a keystone shape of stars, 4 stars that make the body of Hercules. 2 stars, the broad at the top, narrow at the bottom, like the keystone of an arch. And that basically, on the right-hand side there, is where we find this lovely object of the great cluster in Hercules. We can also see stars that are in the process of losing their energy and dying. This is actually a ball of hot gas, which is actually the remnants of the star as it dies. And as the hydrogen is starting to run out and most of the stars convert into helium, at least in some parts of it, it puffs its outer layers into space. And in the process, the core begins to shrink back and cool. And what we're seeing there is the outer layer of the star puffing into space, with a little star in the center being all that's left. Now this is an object we call the Dumbbell Nebula, but I prefer the American name. It's the apple core, because it does look a bit like a juicy red apple with a bite out of either side. And you can find that by finding the Northern Cross. The bottom, the head star of the actual Cygnus Alvaria, come left and roughly make a rectangle with the first wing star, and you find this object. Again, shows up in a pair of binoculars just, but shows better in a telescope. You can even see stars where there is no longer a star left, but the star's exploded and become a supernova. So it's probably worthwhile saying there that I've mentioned before nuclear fusion, where hydrogen fuses together to make helium. Well, all of the elements that make up the universe are effectively created through nuclear fusion and that chain building up. And stars can only make things up to about the atomic weight of iron in a stable form. Anything heavier than iron can't be formed in a stable star. It can only be formed when a star explodes violently, when the heavy ones eventually die and they collapse down. They have a secondary explosion called a supernova. And the temperatures and pressures involved in when that happens are so large that all the heavier elements can be formed. So the gold that makes up my wedding ring, the calcium that makes up my bones, were caused in the instant of a star's death in a supernova explosion. And we can see remnants of that happening in the night sky just under the left wing of Cygnus here in what we call the Veil supernova remnant. And that's just one part of it. You see there the thin wisps of material ejected by the star being pushed into space and happen to be passing a nearby star. So rather prosaically, it looks a bit like an old-fashioned wooden broomstick with a bristles at the bottom and a hand at the top, and looks like the star's riding it. So we call that the Witch's Broom Nebula. Yes, I know, astronomers need to go out. So I mentioned before the faintest object you can see in the night sky, and I'll probably bring it to a close after I've shown you this. So the way to find the Andromeda Galaxy is to find the W stars that is Cassiopeia, to the right of Polaris from where you find Ursa Major. And the right-hand side V in the W points down to a brightish star, which is in the constellation Andromeda, and roughly a third of the way back, you'll see a little lens of light. And even through a small binoculars, you can actually see it's a galaxy just like our own Milky Way. And as I said before, that's something you can see with the naked eye, even without using a telescope. But you can see it much better when you place it like this, where you've got a really cool night sky with little or no light pollution, which is one of the reasons why I love coming out and talking about it, places like this. So that's 2.5 million light years away. So if you think about it, if you were on a planet going around a star in that area, looking back at our own Milky Way, you'd see something similar from their perspective. But of course, you wouldn't be able to see us as a society because we didn't exist. Because it's taken light 2.5 million years from that galaxy to reach us. And in inverse, it would take light from us 2.5 million years to reach them. So they'd see us as we were 2.5 million years ago. Fascinating, isn't it? So I'll pull it to a close there and say I hope that was interesting, and perhaps it's whetted your appetite to come out on a clear night, perhaps grab a pair of binoculars, maybe even come on one of my talks, shameless plug, where actually I take people out and show them the night sky with my telescopes So here's my website, my contact details. My website's called stargazingevents.com, and there's nothing better than actually being under a clear night sky. So it's a shame we couldn't do that tonight. It was virtual instead, but I hope you've enjoyed it. Thank you very much. Again, I'm happy to take any questions. I'm not sure if there have been any appeared online.
I think there were some people listening to you who haven't had them yet.
Let's take a few questions from here. Just for those people who are on Zoom, we have about 40 people in the room here. We probably have about 80 or so on Zoom. So there's a good, why don't we try and start off some questions here, and then maybe Anne will read out some of the questions that may appear in due course from the Zoom audience. Are there any questions from the floor?
Let me start it off by saying, let's have a show of hands. Who's got a telescope of their own? I guess there's a few. About how often would you say you manage to get it out and to use it? Once a month? A lot of people ask me, what's the best telescope you can use? And that really defines the answer. The best telescope you can use is the one that you use the most, the one that you find easiest to use and set up. So in all cases, something that you can grab and go. You can actually avoid the worst of the British weather. You can see a hole and go out. So often it's not even a telescope at all. It's a decent pair of binoculars. So if you go outside with a decent pair of binoculars with an opening probably 40 millimeters in diameter or to 50 millimeters, no bigger, they get too hard to hold, really. And with a magnification that's reasonably low, because you don't need magnification that much, you just need light gathering power. So even a pair of 10 by 50 binoculars, like probably most of us have for bird watching or whatever, you'd be amazed what you can see, especially if you point at areas of the Milky Way. And many of those objects I showed tonight would show up in binoculars. And if you do want to go down the telescope route, really what matters is the aperture. Don't get one with electronics and everything like that. They just take too long to set up. Something that you can use easily is really the best way to start.
So I'm going to, if there are no questions, which would be extraordinary to me, I'm going to provoke a question. And my question is just the topic which a number of us have discussed just before this presentation, because we're very fortunate to have within our community here in Glenridding and Patterdale some people who are avid star gazers, and we are thinking, should we have in this community an observatory or some sort of facility that would be permanent? We could start off temporary, because I understand you can even have blow-up planetariums these days. Do you think it's something which we as a community should take inspiration from this talk tonight and come together and see whether we can create something like this? Because my sense is that there's something like 30 people on our Dark Skies WhatsApp set up by Sabine here in the audience a few months ago. I believe I'm so passionately interested by the treasure trove you can see in the sky above us, but very few people have the knowledge and experience to explain it to us. Is that something that we should try to work towards?
Yes. Yes, somebody's saying yes in the chat.
Because we heard just before we spoke here that there are other places in the north that do have observatories. We do have within this community people who are interested in creating one or more observatories. We do have, and here Robert has experience of running blow-up planetariums even.
And full
Would you
observatories.
like to explain a little bit what that looks like?
Certainly. I mean, an observatory really is just somewhere people can come and see the sky. But of course, you're still affected by the weather. Now, observatories, we often have decent permanently based telescopes that allow you to see very, very far away, but they still can't see through clouds. So most observatories that really operate during the day as well at night tend to need to have a way of actually talking to the screen like I've done today, or more immersively show people a planetarium. So I don't know if any of you have been to the National Space Centre, where they've got a lovely permanent planetarium. You can actually go inside and see simulated night skies with a real 3D immersive experience. You can actually do the same thing in a room like this, with a pop-up inflatable planetarium dome, a bit like a bouncy castle kind of thing, with a projector inside. And especially with the kids, I've been taking things like that to schools for many, many years. And when I was up in Galloway in Scotland running the observatory up there, we did that. We took the observatory to the schools. And in a room like this, where you can inflate, say, a 6-metre dome and actually show the kids a pretty realistic view of the night sky inside, is a real way of instilling the passion that I hope you hear that I've got in the kids as well, and making them hopefully protect the night skies around us in their own adult life.
There's a question here.
Question, good. Why don't you read it out?
Okay. So it's from Kevin Cumming. What is the process like to try to achieve dark sky status for an area? Is it a lengthy process?
I'll repeat that. So what's the process like to achieve night sky status for an area? Is it a lengthy process? Yes, in short, it is. To get the full dark sky protected status that I mentioned that some of those 17 had can be a very long process, and it involves a lot of stakeholders, a lot of paperwork, a lot of getting people on side. And really one of the things that's inherent in doing that is getting light limitation and light design built into a planning process. So if you're part of an individual authority that, like a national park, where they are their own planning authority, it's relatively easy. If you're an area like we are in this area, where it's a multiple landowner area, it's much harder to get all the stakeholders involved. But it is a matter, probably you can take about 18 months or so to go through the process. Not excessive, certainly not expensive either. The difficulty is making your case and getting people support, and making your case involves taking measurements of the night sky to demonstrate that you've got a sky worth protecting, and that's easily done when you can see the likes of images we've got tonight. Yes?
I was going to say, isn't the Lake District National Park, they've got a dark sky officer, and aren't they doing that because the person changed about two years ago?
There are moves afoot.
Halfway through the process.
Yeah.
There
There is an issue, there is an activity going ahead to do that, yes, in the Lake District. But I think there's an opportunity here to make it a wider area than that. Because in the Lake District area, perhaps the very core is bright, but there are actually quite a lot of lighting in the areas around that core. When you actually look at the whole of Cumbria, we've got a lot of dark skies that aren't in the Lake District. So if we take a more wider view of it, and we can actually get more protected areas, my point of view. But yes, there are activities going on. And really what I'm saying is, asking for people like yourselves to be supporters of that and work in your own environment where you make sure you aren't contributing to light pollution with your own properties. And if you're an accommodation provider, for example, it's really a win-win for you, because you can actually attract people to the area by realizing you've got a dark sky offering, and you can also get people to come to the area outside of the normal season, making the shoulder seasons longer, especially if you take the time to actually make yourself more dark sky friendly and advertise to the wider population.
We've actually got on the call, hopefully, someone called Jack Ellaby,
He's just written something.
who some of you in this room will know, who's done a report, I believe, on this community. And we're already taking steps to change some of the light bulbs in Glen Reading. But Sabine, maybe you could explain where we've got to on that exercise.
Not much to add to what you just said, and Jack is on the line. But Jack has organized Cumbria Night Sky as well. Is it about enough close? I don't know, then it is there where the lights have changed in Glen completely. And my understanding is we have some regular feedback from people. So that's already happened. I know Rob is looking further potentially. I think Jack was going to organize an outing later in the year where Rob comes up on a parish council, which is done stuff. And there is some money available out there, particularly the carbon savings at the same time, which should usually be available, because if you're not beaming light into the sky, then you're probably creating a pollution at the same time. That's carbon. So there is some work underway to get that off the ground, and as said, broader program of creating dark sky reserve.
I don't know whether Jack can speak to us. I'm not sure that works.
I'm not sure, but what we can certainly do is save the chat, and we can send it to anybody who wants to. There's another question for you here.
So just to finish that, so in short, the community here in Patterdale already is quite well advanced. Already a report has been commissioned. and the council is very much interested, I think, in this. So we're hoping that this event, amongst others, will take that stage.
Shall I
further.
try and see if I can let Jack speak?
See if we can, yeah.
Just
See,
a
we
second,
haven't,
I'm
we
gonna
haven't done
have
this
to change
before.
the camera, I think. Jack, can you unmute yourself, please?
Can you hear me?
Yes, we can.
I could say loads of things, but Sabine's right. We've had a report done looking at the main light pollution sources in Patterdale Parish, along with other parishes. So some of the light sources have been obviously involved with the hospitality industry. So we needed to let them get established in terms of business post-COVID. So we will be approaching them from November onwards to see if they're willing to change some of the lights. Fortunately, we have no statutory power, so it's going to be a matter of persuasion. So that's why events like this are important, because the more people who care about light pollution, as Robert's saying, we're going to win more hearts and minds. And hopefully tourism businesses will recognise that visitors will want to come to their businesses if they know they're going to see an amazing starscape, particularly over the winter months when perhaps there isn't as many tourists normally. But yeah, there's loads of exciting things happening. I'm hoping to persuade the Cumbria planning authorities across the whole of the county to agree to a supplementary planning document about lighting, so we can get the lighting right everywhere, not just in the deep rural areas, as Robert was hinting about, where the night sky reserves might be.
Let me repeat that for the people in the room.
Yeah.
Basically, Jack Ellaby was saying there that there are moves afoot, there's moves afoot to get the funding that will allow this to start. There are certainly strong steps already to actually get the local planning authority, Cumbria Authority, to have a planning awareness and planning restrictions becoming to be in place. I'm paraphrasing Jack, but I'm sure that's pretty much what you would have said if you'd have to say it out loud. So it's moving in the right direction, but the more support, the more hearts and minds we can get on board, the better.
Any more questions? Yes, please, George.
The universe is expanding. Do the constellations become distorted? And are there constellations that the Greeks or the Chinese or the Persians wrote about that we can't see today because they've died?
It's an excellent question. So basically, for those that couldn't hear that online, I was asked if the constellations we see today are constant because the universe is expanding. Have they become distorted, or perhaps have they even disappeared over time? In short, yes, but not in human lifetimes. So, for example, the constellations that we see from our perspective on our planet in our own galaxy is purely a consequence of the angle of the stars we see around us and the way those points of light appear to make patterns. And of course, it's the human brain making those patterns. They're not real patterns at all. But if you actually wind the clock back, the stars do move over time, but not significantly, not hugely. And to put it in context, our own sun orbits around the center of the Milky Way galaxy. And if I remember correctly, that's 250,000, 250 million years to make a single orbit. So it would have to move a long time to make those stars appear to move appreciably. And that's much longer than a human lifetime. So you can actually use that Stellarium software and wind the clock back. And the proper motions of stars, which is effectively the term we use for the movement, is actually built into it. And you can actually see that over time they do move, but not really enough to make any difference in a human lifetime. Even going back thousands of years, the changes are very, very small. So most of the constellations we see are the ones that our ancestors saw. In fact, in the Lascaux caves in France, there are cave paintings. And some of those cave paintings we now realize are star maps. There's one where there's an auroch drawn on the wall. And at one point we thought it was a hunting scene. We now realize there are points of light making a V shape in the head of that auroch, which is very much like the head of the constellation Taurus. Now you can easily say, oh no, that's fanciful, it's not true. Then you look slightly to the right, and just above the back of the auroch, there are actually 7 little stars in a little group in exactly the right place for the Pleiades constellation. Now that is going back a very, very long way. I can't remember the number offhand, but basically cave paintings in Lascaux, France are a long, long time ago. Yes, Sabine?
The very interesting, there's a brilliant book online called The Human Cosmos, which is the sort of history of science, but basically based around what was born of the star. And it's available as an audiobook on BorrowBox, which is the Cumbria Library online facility. So just go to BorrowBox and The Human Cosmos. It's great.
Super. So she was advertising for the Human Cosmos, I think. Any more questions online?
there's one from Kevin Cumming. What impact, if any, do onshore wind farms have on dark skies? Often cited in rural locations, likely to increase in the UK.
Again, for those that couldn't hear that from the microphone, what impact do onshore wind farms have on dark skies? Very little is the short answer. Even in places where the wind farms need to be lit to prevent low-flying aircraft issues, they're lit with infrared beacons rather than visual red light beacons. And the tall structures having the odd red light on them is tiny of an issue in comparison to the lights we get from major towns and cities, and in Shap, that quarry I mentioned before. So a very, very low impact at all. In fact, in some ways, you could see them as a benefit because they tend to be areas which are kept relatively wild in between the actual turbines themselves, and the infrastructure associated with the turbines is very, very low intrusion. So personal experience, when I was up in the observatory in Galloway in Scotland, we had several wind farms around us. I never had a single problem with any of them, and I don't think they're a problem at all.
Okay, any more questions from the stars? No?
There's lots of people saying brilliant presentation.
Okay, Gordon, would you like to say something?
Yeah, thanks, Rob. From where we are now here in Glenridding, where would be the best 3 places within, say, a 5 or 10 mile radius max to view the night stars?
Unfortunately, I don't know the area well enough to really give you a good answer on that. If you looked at that map I showed earlier on, you can actually see the overall view of the light distribution in the area. Pick somewhere dark, pick somewhere away from those points of light. And obviously, the farther you're willing to travel, the darker, the better opportunities you'll get. The things you want to be looking for, generally somewhere high, which means you have good low horizons around you. When you're in a valley, you're limited by the valley side from what you can see horizontally, especially if you want to look at, say, the northern lights. You'll need a low, clear northern horizon. So somewhere high is a first good one. Somewhere dark, even if it's actually in a small bowl where the local trees perhaps protect you from the surrounding lights, you can get some amazing areas really quickly.
Yes, Martin.
We tend to go to Matadale Common, Glencoyne Car Park, and Red Screens.
Do you want to repeat that?
So, Matadale Common, Red Screes, and Glencoyne Car Park for those on Zoom. Apparently the best sites locally to see the night sky. Okay.
I probably shouldn't say, but there's quite a good one at Matadale End, you know, on the road that goes up round the back.
Yeah.
Past the forest, it's a good bit of place to park. That's where I took the pictures of Neil last time. Okay. Yeah.
It's very good from our house as well, I have to say.
Very kind of you, thank you.
Any more questions from the floor? And any more questions from anyone?
Oh, Acott Hill is suggested.
Acott Hill, okay. Sabine, I see you're sort of.
Just moving around, I don't know whether you want to give a clap for what afterwards, if people want to join, drop your line or drop your line or something, and we'll just get them on.
Yeah, first of all, I'd just like to raise my hands to thank you so much for such a rich talk. I mean, it's fantastic, a treasure trove of information which is waiting to be discovered. You gave a brilliant presentation, really inspiring, and I hope, I'd like to see some more children in the room. Maybe we should be inviting you back to talk to some of the kids, because I think you have that sort of, I don't know how you call it, but real sense that people have that excitement and motivation to see what's in this. So thank you very much. Can I just also go back to something I raised at the beginning? Do you think, is there enough interest, both in this room and online, to take this further? There's already something happening within our community, but we believe there's a real interest, and if we can go towards an observatory or some sort of facility here, can the people on the Zoom sort of show their thumbs? And in this hall, do you think it's something that would be willing to do? I mean, get together, maybe we can, those already on the WhatsApp group can come up with some ideas and distribute them amongst the community here, and then we can take this issue up again.
We've got lots of thumbs, and we've also got our 14-year-old enjoyed the presentation. Lots of kids watching.
So 2 more points. One is we brought into the hall 6 panels that we inaugurated last week. The Ullswater Steamers very generously offered us a cruise to launch what we're calling our Ullswater Heritage Knowledge Bank, which explains our desire to gain stories from the community about our local heritage. And there is something in that bank on stargazing, on dark skies, just to encourage those of you who have not contributed. And in this hall, there's several people who have written articles for that Heritage Bank. We would encourage those who have a story to tell on any subject, memories, or particular scenes. I see several people who are contributors to that bank of information. Please don't hesitate to contact us. We'll leave the posters up so that people can have a look at a later stage. And finally, we will have another talk in a month's time given by Jeff Cowell, who's a senior volunteer at the Lake District Planning Authority. He's going to talk about the imprint of the Romans in this area. And he's given a talk once a year ago, maybe more than that. And he was very, very impressive. At that time, the village hall in Pooley Bridge was filled. And we're hoping to have the same sort of audience with him. And we'll probably try again, I suppose, to do a combination of the Zoom call and local participation. Thank you very much for all of you here who come tonight. And apologies again if some people came, I got the timing wrong. Thank you very much to all those who are listening online, and have a good night. Thank you. Thank you. Do we put some lights on?